What's going on? Wow, this is a
So
very special live stream. I gotta say, I'm a little emotional about this one.
yeah, oh, yeah, me too. It's been really a lot of fun, and really, if you look at it, I joined NVIDIA about 2 years ago, and I started doing these live streams not long after, and so it's really kind of been following my NVIDIA journey up until now.
It's been a
Yeah,
big one too, man. I
yeah,
mean, I think, first of all, thank you so much for doing these live streams. They've been fantastic, just fantastic for the community, fantastic for us because they've given us great information about what people have needed more help on, which I guess is paving the way for your next focus, at NVIDIA, which is helping build the training and the tutorial doc. So I guess the whole idea in summary is that, and correct me if I'm wrong, but by having your time focused on the training, documentation, tutorials, things like that, people maybe more impacted by your time there than they will in the live stream series here. Is that kind of the gist of it?
Actually, I don't. I think it's not quite because there is a different group who's in charge of the training documentation.
Mhm.
To my knowledge, I'm mid transition and I'm learning myself, and so there's still uh, uh, some uncertainty for me there because
Yeah.
I'm learning what my new job role means.
I think it's similar. I think it's pretty similar to Ashley's kind of transition, which he talked about on this week's live stream
Yeah,
with her audience. So, but but I want to be clear also that Eric, you will be still doing live streams.
yeah.
We're going to be grabbing you at different moments of the year to kind of share knowledge and kind of walk through different workflows on the USD development side of things. So you're not going anywhere.
I'm
Um,
not going anywhere, and I would even say that um, if you think about it, like with these live streams, I would typically choose some kind of a sample or a demonstration that I thought would be helpful, and then I would kind of carry you along with me as I develop that.
mhm.
That's what the format's been, and I think they just really liked those end products of those samples.
Mhm.
Um, we call them different things sometimes, but I still be developing that sort of thing, those kinds of samples. And I think the difference is instead of live streaming completely as we go, once it's done, then I'll do a live stream and kind of launch it and share the sample.
Yeah, that makes total sense. Total sense.
Yeah, and
Um,
it's gonna mean I have more time to actually complete the samples, which should mean more samples like that.
yeah.
Yeah.
Well, I'm very excited. So, what? Let me see. Before we go into a deep dive in today, kind of what's the high level of what you're covering today?
Today we'll be talking about synthetic data a little bit and synthetic data generation. Oh, sorry, and domain randomization. And I'm so sorry, my light is so dang crooked, it's driving me nuts. So I'm just gonna like step back here and fix my
All right,
crooked
good.
light.
Actually, it's a great time. I'll do a couple quick announcements. Let me just bring this up to slideshow and share my screen. But yeah, there's a few quick things we can go over. Um, one of which
That's
is yeah, looks very nice.
thank you.
So we had the OpenUSD training labs from GTC are now available, and these are the labs that actually you were involved with, Eric, at GTC, and Jen and Ashley and Paul Cutzinger, and many others from our team. So these training labs are now available. I'll post the links in the chat right now. Definitely feel free to go through there. It's a great free resource. There's no reason to not do it. There's every reason to do it. There you go. They're in the chat right now. And then on top of that, the other sessions are available also on demand and for free. Right after GTC, there was a short period window where only registered attendees could access. That's kind of par for the course with GTC. One of the benefits of registering, even for free virtual. But now all these sessions are open and available to everybody. Amazing wealth of knowledge and sessions from experts from all over the world, in and outside of NVIDIA, of course. So we will put that link to that in the chat as well. But I hope everybody takes advantage of that. If you have any questions or you're having a problem accessing anything, definitely let us know. You could always shoot me a note on Discord. My Discord ID is Edmendi, EDMENDI, or just hit us up on the Discord server and the GTC channel we've got there. Okay, so there's a link in the chat for all the GTC sessions. One of the GTC highlights was actually talking about what Siemens has been doing with OpenUSD. The scene you see on the screen was actually displayed in a live real-time demo at the NVIDIA area of GTC. My colleague Richard Yartlett was actually one of the people that was showing this off. Really beautiful stuff. So take a moment to actually look at some of those great spotlights on developers. And let me actually put that in the chat now. And I think the main thing here is that you'll be amazed and inspired by some of the work you see being done with OpenUSD and developers in the world. So that link is currently in the chat. And then last but certainly not least, regarding OpenUSD, we've got a great community challenge right now. We would love for people to share your OpenUSD kind of work. If there's a first time you're diving in, if you're a veteran, share your project on social media. Use the hashtag OpenUSD challenge. And I will actually put a link in the chat for a great resource, which is a nice forum post that goes over everything. We would love to see and share and celebrate what the great work you all are doing in the community on OpenUSD. That being said, we've got a lot to cover, and we've got about a little bit under an hour now. So yeah, so let's get the party started.
All right. Just launching Isaac Sim in the background right now, and then once I have it open, I'm going to open the that F-110th car scene that we were working with at GTC, and we're going to talk about kind of what's next. You know, where do we go? So we now can train a car using supervised learning to drive around the track.
That's amazing. One of the questions we got kind of right after GTC, and you and I chatted about it on Slack a little bit the other day, but was when these kind of assets will be available to the public to fool around with. And I think you said you were still working on that, but soon.
Yeah. And it turns out that I made a mistake with the licensing. How I was setting up the licensing, I forgot to mention that we're using some open source libraries, and so I have to. It just takes you longer than you wish it would to do these things right. So,
but it's in progress and it's going to happen. So people,
that's my number one task right now. And if you remember, my new role is to release samples just like this, and so it's well within my role to, or that's awesome. That's my top highest priority right now is to get that sample released to the public.
And to remind everybody, so you have a great active channel on the Discord server for Omniverse on the Jet Racer project, which you're using for all this. So if you want to chat more about this, I think the channel name is just Jet Racer. And you could come on to the NVIDIA Omniverse. I'm going to put this big banner on the screen. You can come on to
I like it.
Yeah. I think Wendy did this.
We got some new assets to share.
That's funny. So yeah, so that is the URL for I'm sorry, this is so obnoxiously big. It's discord.gg/NVIDIA Omniverse. This is so you'll never forget it. Definitely feel free to join with the community there. We would love to see you there and chat about the project. And we have a channel specifically for the Jet Racer project. All right. Okay, cool. How's Isaac Sim coming along?
Good. It's making me log in with single sign-on.
Okay, cool. Great to see some familiar faces in the chat. We are streaming to YouTube, Twitch, and also X, formerly known as Twitter. I wonder how long we have to say formerly known as Twitter for. But yeah, feel free to jump in the chat. I see some great familiar faces. Zia, of course, I think he has got to be the most regular viewer we've had on all of our series, and he's such a great part of all these live streams. He's almost like a co-host.
Great question from. Sorry, he's asking, will streams be changing to every other Thursday? And no, I'll be hosting some of the Wednesday live streams moving forward. Yeah, and I think there's not a set pace, but maybe once a month. Is that about right?
So at a high level, so just for everybody out there, we're going to actually be putting a lot more focus and effort and production quality into the Wednesday live streams. And we're going to be matching a cadence that follows some development announcements happening throughout the year. so that the community can really dive into those things and have great content, supporting content to the announcements and other developments that are available. So there's a lot of work happening now in planning that roadmap. We're going to talk about it, more officially in the coming weeks. But yeah, so Eric and Ashley and Jen will definitely be part of the Wednesday live streams that many of you are already watching and a great part of, every Wednesday at 11 a.m. Pacific. Give us your feedback too on the live stream. Let us know what you benefit from seeing more on these. Really excited about a kit one that's coming up soon. We're getting that planned right now. And we have a great live stream next week. We haven't really formally announced it, but with SoftServe and Continental, really two great companies leveraging OpenUSD to help their clients. So we're going to look at some of those use cases next week. But great to see that question here and the other people here. All right, we've got Isaac Sim looking nice and sharp. Look at that racetrack.
Oh yeah, looking good. Yeah, so let's see here. So if you've been following along, you've recognized some of these assets. You recognize this F-110 car. By the way, we're working with Onshape we used Onshape to develop the CAD model of this car. I've got a CAD template you can use and customize. And when I share the assets, I'll be sharing this open source asset as through Onshape. And I just want to point out a subtle difference between this open source robot and other open source robots that I've seen. And that is other open source robots are not, they're not like open source code, okay? When you release code open source, you actually release the source code. And so someone could contribute and improve that application, or they could make their own copy and write their own version of the application, right? All of the open source hardware that I've seen, they release STL or step files, IGES files. They basically release dumb geometry. So I would equate that to releasing your binaries of your compiled source code and saying, okay, here's the open source application. Here are the binaries. Well, it's not really open source, right? That's like it's just really like binaries with a friendly license, okay? What we're doing here is much closer to true open source because I'm releasing the design level CAD files in Onshape. And that means that if someone wanted to step in, and I don't know how we would do this exactly, but if someone wanted to make some changes to it and submit those changes, I think we'll figure that out. If someone makes some significant contributions, right? If you want to take a copy of this and modify it, change it, use it in your own, and actually change and edit the parts, you can do that. So we are really and truly, it's really and truly like an open source CAD project, an open source asset. And it's really, it's just something that hasn't really been done to my knowledge up until now, because it's, I think it's in part because I don't know where you would host the files, right? And in part because there was all of the CAD softwares that, like if I use most commercial CAD softwares to produce assets like this, you really can't share the design time parts publicly because people need to purchase that CAD software in order to use them and access them, edit them. And that's what's so nice about Onshape is they have a very friendly, free tier. So if you go to Onshape, you can sign up, you can use it for free as long as your stuff is public and kind of open source in this way. And actually, that's
awesome.
that's maybe where I've misspoken, to be honest, because really there are a lot of open source projects available on Onshape already, right? You can go there. It's really kind of it's really a great resource, and I hope that more of us will pick it up and make more of these open source robots that are truly open source. And maybe we need to come up with a new name, but they're open source to where people can actually edit the CAD files and repurpose them for whatever they need to use them for, and not just use a completed robot.
Yeah, that's a great kind of call to action there for the public. And also, can we mention what we were talking about yesterday about a future live stream?
Yeah, I think so. Totally.
All right,
They
so go
love
ahead.
it. They love it.
Tell them what you're planning.
So, Onshape has got this great startup program, and they want to join us, and we're kind of this collaboration is starting because we love Onshape because Onshape is letting us do this truly kind of open source robot like we're doing with the F-110 car. And Onshape loves us because we do robotics, and a lot of their startups do robotics. And so some of the folks from Onshape are going to join us, and we're going to talk about their startup program. And it really, for you, if you've got to start up an idea and you need to use CAD, and you don't know how to get access to free commercial quality CAD, this startup program is for you, right? This is how you do it.
That's awesome. That is so exciting. I can't wait for this one.
Yeah, it's going to be great. And I think that'll be in the next month and a half that we'll have them on. We're going to talk about this, and I'm really excited for you because it's really just one of the major roadblocks that I've seen since I started here at NVIDIA is I've been trying to facilitate small business. But if you don't have any CAD software, and you're a startup and you can't afford it, especially if you're, more like me where you don't have startup venture capital funding, but you're just trying to bootstrap your own business and you can't afford CAD licensing. I just really have been looking for, Unreal Engine has that licensing model where it's free until you make a certain amount of money, and then you pay them licensing fees. And the Onshape setup is more like that.
That's
and
great.
It's not exactly like that. We'll talk about it, but
yeah, that's great though. That's awesome. And if for all the startups that are watching this, or if you think about doing a startup, also look at NVIDIA's Inception program, which is also great free resources for startups.
Especially if you're a robotics startup, I would seriously take a look at both of those programs because I think there's a lot of you can get a lot of help from the two, So, so excited to talk about that partnership with them on a live stream in the future here. But let's talk about. And I just got a comment from Zia that I had no idea. Siemens has a free tier, it turns out, too. I didn't know about this. I don't know what it's like or how long it lasts, but I'd be curious to look into that. I think that you ought to use whatever CAD works for you, for your business. And Onshape is really, it's web-based. You don't need a very fancy computer, and I think in a lot of ways it's great for startups. But if you need to do like surface-based models, Onshape, then you need to be looking at more like a Siemens or a CATIA grade, I would say, if you need to do a lot of surfacing or much more complex assemblies. But each CAD software has its kind of secret sauce or advantages and disadvantages. And all right. Back to business here. I've got the car open. And if you recall, and I'm on my Windows computer, so I can't make it go. But we've trained a model using this extension that we wrote. So we drove the car around with the keyboard. I captured 500 images as it drove around, and then I annotated where the car should steer in each of those images. Then we used that data set to train a model to make the car drive itself. And really what that model is doing, all the model's doing is you give it an image, and it tries to predict where would Eric click on that screen. And then we kind of draw some lines based on the pixel location of where it thinks I would click. So we use that to calculate some angles from straight ahead, and we come up with a steering angle and a throttle from that, just using some heuristics. We just kind of made up some code that does that and tweaked it until it worked. We included some fudge factors and some correction factors and stuff, and then we played with those until it would drive around the track. So this is really the simplest self-driving car that I could imagine. And it's thanks to Chitoku Yato's group from Jetson. They came up with this, and I just adapted it to work in Isaac Sim, along with Ayush Ghosh's help, who did the Isaac Ross Bridge. Anyway, so here we are. We have the car, it can drive itself, but it can only drive around this blue track. And we would like to let it drive around in the real. Well, one, we would like to have it drive around in the real world, not just in virtual world. That's a big kind of requirement. And another thing is we would like it to be able to drive on mini tracks, not just this one. And that's another really big thing we'd like to do. And the first one, there are a few ways. We call that sim to real, crossing the sim to real gap. And there are a few ways we could address that issue. And then the other one, we would call that zero shot. So, or one shot, it depends, if it's a one shot, you drop the car on a track, you drive it around slowly once, it captures the track, learns some stuff. And then after that first lap, with some small training, it can go really quickly. Zero shot is you can drop it into any track and it can just drive itself. So really we want zero shot, right? Yeah. I guess there's no half shot. Probably, sure, why not? If you let it drive around half the track and then it can go, then it's half shot, right? Okay. And then in getting to that zero shot, that's really a reinforcement learning problem, right? Where we have a different model that's more complex than this one. I would think, well, I don't know, maybe. I guess I don't know for sure, to be honest. It could be that if you just... Okay, this is the way I would say it. I think you could... So remember, we've got supervised learning, where we're actually creating and annotating the data set ourselves, where you've got unsupervised learning, and there's more than one type of unsupervised learning. But the gist of it is that with unsupervised learning, is you create a system that creates its own data set and annotates it itself, so you don't have to do that anymore. And a really popular type of unsupervised learning for robots is reinforcement learning. And in reinforcement learning, you just give the robot some penalties, like if you go out, drive outside the track, that's a penalty. If you get around the track and finish laps, that's a reward. And you use those penalties and rewards to perform some type of a non-gradient optimization, like a genetic algorithm optimization. Okay, that's kind of the gist of reinforcement learning. And so we could, in theory, train a model to a zero-shot model with supervised learning. What you would need to do is randomly generate tracks. Then for each of these tracks, drive around it and create that data set yourself. And you would have to do that for a lot of tracks, and it would be awful because it would just take so long. Maybe you could crowdsource it, right? Maybe if we got 1,000 people or a couple hundred people, I don't know how many people, a bunch of people, gave them each random track and had each of them generate a data set for that track. Maybe we could bring that together and train a zero-shot model or one, on that bigger data set. But it's pretty hard. And so really what you want is a reinforcement learning thing where a random track is generated, the car drives around the track, and then it can it drives around the track, and then it just kind of trains itself. And maybe we could get clever with supervised learning, right? Or with reinforcement learning. And instead of having it drive an entire track, just have it navigate like a specific corner. If we only have like a certain sizes of bends, then we have a track builder that you can build whatever track you want from these kind of Lego block pieces of track. And then maybe we could just train it to navigate specific corners or something like that. And so maybe there are a lot of interesting questions there. This is definitely not an open. This is a very open ended thing right now. There's no right answer. But okay, back on track. So we kind of have these two directions we can head right now. One is towards zero shot, and the other direction is towards sim to real. Both are valuable, and I think we'll definitely work on both. But I'm going to start by working on that sim to real transfer. And so now there are two options for sim to real transfer. Okay, one option, if we want to, and we worked on this a little bit in the live streams before, is we could go and do a reality capture of the location where we want to drive the robot. Okay. We could then, and I could do this. Honestly, it was pretty close. And I could probably go ahead and do it because I have a reality capture of a gym. I've flattened the floor. And then, and I could just replace this blue grid background with that one. And I'm pretty sure if I trained it in that gym, it would work. And in real life, and Zia says, gonna need cones. I've got cones right back there. I've got cones, orange ones. I've got a gym. I have access to it, a place where I could try this out. I've got a LiDAR scan of the gym. And so we could do that, okay? I think it would work. But here's the problem. Well, it's not a problem, but the weakness of that is it would only work in that one gym. And if somebody changed the color of something or that sort of thing, if someone put other objects in the background, if there are people walking there, it might break it. It would be, so I think we could get it going, but it would be pretty fragile. And great question from looks like Christoph. How do I play a sim? Once you have some physics set up, you can hit this play button and it starts it. See, it's going. And if you hold shift and click on the object, you can interact with it. Oh dear, we crashed. Hit stop to reset the sim. Okay. So how do we train a car that's not going to be distracted by the background, that's going to be a little more robust, that could work as long as we have an oval track? It doesn't care if it's real life or a sim or what. And the answer is through domain randomization. Okay. And if you think about it, if you look at this image I've captured, and then I click on it, when this AI is learning to predict those clicks, it's using all of the pixels in that image. It's using these grid lines. It's using the cones. It's using these background grids. It's using this blue color, all of it. If I just churned this from a blue to a green color, it could break my model. It could be. It depends what the model is learning to recognize. And I don't know. I don't know what it's learning to recognize. The lines, the color, what? And so, see, perfect. Great comment, Zia. From attention is all you need. What if we just tell it to focus on the cones and nothing else? That is exactly right. That's what we want. And maybe not even those cones. Maybe we wanted to just learn what a cone is, what a track pattern it looks like. Just objects laid on the ground, kind of in that pattern. Like if you think about us, I used to go play Ultimate Frisbee. And when it was time to set up the court or the field, we didn't have cones. So what would we use? We'd use shoes, hats. We'd use somebody's t-shirt or jacket. And it's not even, if someone showed up, they wouldn't even have to ask, well, what are those things in the corners or along the sides? They just know that those objects arranged in a pattern were the boundaries of the field, right? And so, but the trick here is that whatever we want the car to not focus on, we randomize. And so, and that's where replicator comes in. So replicator is meant to randomize things in a scene. And so what we'll do here is we'll take this car, and the first idea I thought of to do this, kind of the simplest, we're driving the car, and then every time you click, it randomizes, it takes maybe, let's say, 10 captures, and each capture has a random background. It changes the cones with different cone assets, orange ones, blue ones, purple ones. It adds random people in the background outside of the track, walking, kind of walking around or something. It adds teddy bears back there. So they call those distractors, and just randomizes everything we don't want it to focus on, and even adds things to the scene that we want it to be able to ignore, but randomly. And it's really only the position and the kind of that pattern of cones that we don't randomize. And if we do that, then the model will learn just to recognize that cone pattern. So that's domain randomization. And domain randomization is a critically important feature of AI training that can help us decide what our robot should focus on. And I'm just curious if there are any questions or thoughts coming from you all about domain randomization. If that makes sense, if you have questions, now is the time, because we're going to go on to a little bit more how we're going to do this. And this will be the sample I'm going to start working on next. Well, first I'm going to release this one, and then I'm going to work on this next one. Okay, no questions? Great. So now I want you to think about this. If every time I click, it has to do domain randomization and capture 10 images, that's going to be a pain. That's going to be a total pain, because really, is 10 even enough? I don't know. And so one thing is, we really want to be, oh, sorry, I just got a great comment. What about randomizing friction? That is such a great comment, mission statement. And it's not going to come into play with teaching it to ignore background, but my hunch or my belief, I was just thinking about this over the weekend. I was reading a paper about reinforcement learning for F-110 cars. And one of the problems that they have is that people are trying to create these extremely realistic tire friction models and very realistic dynamic simulation models, so that they can teach the cars to handle high-speed corners and that sort of thing. So I think that if instead of trying to make the simulation very, very realistic, if instead we leave it not as realistic, but we randomize friction and randomize some of these physical properties, I think we can teach a car to just be a good driver. Because if you took a really good driver and put them in a car they've never driven before, and they don't even know the tire settings, or they don't know the tire pressure, they don't know how sticky the tires are. But if you took a professional race car driver and stuck him in a car he's never driven before, he would drive around the track once and test the limits of the tires, and then he'd start to get fast, because he would just feel it out, right? And I think if we randomize friction and that sort of thing, we can teach a car to feel it out. So great comment. Randomizing the surface. Absolutely. So if we want to teach a car to drive more robustly off-road, to be able to control a car even if it's being disrupted, we can make rough surfaces and randomize those. Yeah, great. And another one is randomizing the tracks. So really, anything we want to teach the car to understand more generally, or to ignore, or to be able to ignore, we randomize, right? Let me see here. I haven't even read this one. It just sounds interesting. Okay, would it be possible to generate an asset library where the AI model already has an idea what the model is before you add it to the scene? Yeah, and I think that's kind of what Jim Fan's doing with agents in part. So they're training these foundation AIs that will work with, like, in their case, humanoid robots. And the idea is you should be able to put these models into a variety of humanoid robots, and they work for all of them. In that case, what you're doing is so if you think about this domain randomization, if we are truly random, then I would say that we teach the models to ignore things, right? But if we randomize within a range, we'll be teaching the AI to operate within that range. And so I think with your comment is that, like with a car, if we gave it a range of different car sizes and tire frictions and stuff, we kind of give it kind of a range that it can operate within and kind of feel it out, if you will. Whereas, yeah, and so there's a lot we can. Domain randomization is really, I think, really important, and it's one of those rich, like, things that seems really simple at first, but is really quite rich. So there we go. Okay, so really, okay, let's say we pick those 10 images that do that 10 image thing, though, right? So every click, we do 10 different backgrounds and 10 random backgrounds. And let's say I train on that, and that would take maybe a few hours of training, because every click takes a few seconds. It'd be fairly tedious because you have to click and wait, every click and wait. And then let's say you train your model and it doesn't transfer. It can't cross the same zero gap. So now I know I need more than 10. I don't know how many, but this is all hypothetical, right? I just need more than 10, let's say. I don't know how many I need. So I just try it again with 20. Maybe that works. Maybe it doesn't work. Maybe I have to do it again with 30. I don't know. Yeah, it's you can see this is just not a great workflow, right? It's just not as general as you might like it to be. So I was proposing a different way. I think that one requirement is of this kind of a system, where we're going to be, and I think of a lot of just a good general requirement, is we need to be able to parallelize our rendering, and our rendering, this domain randomization and rendering, ideally should be done as a post-processing step. So I go around and I capture one data set, and as in some sort of post-processing operation, I should be able to revisit that data set and randomize it. So one way you could do that, for example, one way you could do that is, rather than with every step I click and it captures 10 images, instead, with every click, it could capture a segmented map. So let me just show, just for those who aren't familiar. Here we go. Just a second. Here we go. Let me pop this up. This is a segmentation map. So you can see this picture with a car and a bus and buildings. And it, instead of being the actual picture, it just has these color blobs that show where the things are. And with Replicator, you can do this. You can capture a segmentation map. So let's say that we captured a segmentation map. Then what we could do is we could take the picture, the spots where cones go and spots where backgrounds go, And after the fact, it's a post-processing step, we could replace all of those with different assets. And we could make random scenes that way. Okay, good question. Are we still talking about a reinforced learning approach? Right now, we're just talking about sim to real transfer. And I think this domain randomization of the background is going to be critical for sim to real transfer. And so really, I would say we want to have an advanced model that has sim to real transfer and is a reinforcement learning based model. And so these two things go in hand, but no, we're not talking about reinforcement learning specifically. We're talking about just randomizing that background and the cones so that we should randomize other things like the positions of the cones so that I don't have to put them in exactly the right spot for it to work. But yeah, okay. Which brings me to my next point is if I did that segmentation map method, would I be able to reposition the cones? No. Would I get shadows from the cones to throw off the model? I would not. Would I be able to change the lighting? And no. I would only be able to do limited randomization. And here we go, just a second. Yeah, great question. What would yield the best results for synthetic data generation? You talked about saving the segmentation maps, LiDAR, PCL samples, or another. Yeah. Yeah, what about LiDAR, right? Yeah. So another one is what if you add a LiDAR to your car and you want to be able to add that to your simulations? And you couldn't do that with the segmentation map way. So let me share how we're going to do this. Okay, here let's take a look at these layers. And let's go ahead and create a new sublayer. And we're going to call it, just going to call it domain. We're going to move everything into it. Okay. I'm going to make another layer. I'm going to call it randomize. Or actually delta. Okay. So I'm going to make this an edit layer. Now check this out. If I hit play, it's adding all of my deltas into this layer. So let's just drag this forward. I'm going to pause it and then save this layer and stop it. Now check this out. Let me see here. Did something wrong. Oh, I know I did wrong. Let's go to edit preferences. Let's go to our simulation preferences. Or visit physics. Here you go. Reset on stop. So now when I stop the simulation, it won't go back. Let's see here. I had the hardest time with this. There we go. Sorry, the shift click thing isn't working for me. Well, let's just kind of, oh dear, that's a mess. Oh, the simulation's not running quite right. Why not, huh? Let's just start over here. Oh, I actually did this already. Let's open the one where it's already working. There we go. So I've already done this in this scene that I made. And you can see I've got my time equals 0 and time equals 1 steps. And if I mute time equals 0, the car goes back to the start. And so basically this T1, all it holds is that repositioning of the car to this time step. And so what I'm going to do is whenever I click to collect an annotated data piece, instead of saving an image in that click position, I'm going to save a delta layer like this. I'm going to save that layer that puts the car in that position, and I'm going to save where it should click. And what that will let me do, is I can grab any of those time steps, and I know the position of the car on the track. I've got all the 3D positions of the cones. I've got the whole scene, and then I can do whatever domain randomization I want. I can just open that scene, randomize the cones, add things to the background, change the background, change the lighting, and I still know the direction the car should be steering towards. So I can randomize all that as much as I want in a loop, post-processed. I'm not there. It's doing it itself. It's just generating data for me, and do as much domain randomization as I want. And if I train on it and it still doesn't work, I just run it through another loop, right? Just generate some more. And it can we can change the positions of the cones. It'll have shadows. We can change the cones themselves. We can change the background. We can add other randomization features later if we want. It's all by working through OpenUSD. So rather than save images as snapshots, I'm going to save OpenUSD time steps as snapshots. Yeah. Whoop, whoop. Yeah, thanks. So that's the plan. And since we can generate unlimited synthetic data that way with whatever randomization we want, I'm just really confident this is going to do the sim-to-real transfer in general. So if we just have just kind of a loop track, even if they're not perfect, even if the cones, if I just went and kind of just put the cones in place, they might have to be the right number for now. But we could even write a script that, given the track, that center line, it does different numbers of cones along it in different spacing and randomizes the cones. So that just in general, if we just follow a loop and just set up cones along it, we could the car would drive it. And yeah, kind of cool, right?
Beautiful.
Yeah. So that's the idea. And I think that should really nail down that sim-to-real transfer. And I'm just also really confident because one thing we did on a previous live stream is we just took that model we trained in this blue grid, and we put it in the LiDAR scan of the gym instead, and it almost worked. The car, you could tell that the car was trying to steer, couldn't quite figure out where it was, but it seemed pretty close. So I think if we just do a couple of random domains, especially if we include that gym in the randomization, I think we're going to get this going pretty quick here. So, yeah. Any questions? Yeah, I like what Janisku said. Unlimited data. Not only that, but I want you to keep in mind that we've got these Omniverse APIs coming down, and one of them is going to be a USD render. And so that means that as these APIs come out, we'll be able to not just generate unlimited data, but scale the production of that data as much as we'd like as well. So if you need to generate 100,000 images, you can just scale it out and generate them really quick through these APIs. So really cool stuff.
Just laughing at that comment that just came through.
Yeah, there you go. It's like student loans, right?
No.
Sorry. Yeah, well, that's the reinforcement learning policy, right? And so that'll be next. That will be we want to cross the 70-year gap and really nail it. I'd like to get it so that I can set up the cones anywhere. Not really, when I was thinking about doing it before with the LiDAR scan, I was kind of like, okay, I'm going to have to get a tape measure out and measure out the exact positions of the cones and put them down the exact right spots. But I think with the randomization, I should be able to just go down and just put in a generally decent loop and just have it run the loop. So there you go. That's the plan. And so first I'm going to release the current sample. And then after that, my next task is I'm going to start working on that domain randomization sample. And so once I get that working, I'll package it, get it ready for release, and we'll have a live stream and we'll talk it over and how it went. Yeah. Here we go. Just a second. I would suggest high iteration of the sim to church gym loop early on, 50% sim than 50% real, rather than spend 80% of the upfront time in sim. I think as far as robotics, if you have a robotics company, I agree completely with what Zia just said, and that would be a good approach. I have a little bit different job. My job is to really get this sim to real thing working well and show people how to do it. So we're going 100% sim. Not because that's the best practice for robotics, but because I think it will be the best practice one day when we get better at this. And I want to start that journey right now, making that the best practice and figuring that out. So the MVP for the entire loop would look like what? I think the MVP is I can go to a new environment with that number of cones. I can set them out in a loop with, being somewhat careful, but not taking hours and hours. In about, let's say 30 minutes. Let's put like a time. No, say an hour. So in 1 hour, I can set this track up with the cones in a new location, put the real card down in it, and have it drive the track without ever having seen that environment or that track before. So it's kind of a zero shot in a way, but it's a familiar track, but an unfamiliar background. And the cones shouldn't have to be perfect, right? They can be a little bit out of position. Maybe I even forgot a few, that kind of thing. So that's the MVP for this next sample. Yeah. And what I would love to be able to do is go to a conference and do a live lab where we show that off, or do it on a conference room floor. Yeah.
That'd be fun.
That'd be so fun, right?
Yeah.
And
what's the next big conference coming up? SIGGRAPH, I guess, is the next big one. There's a bunch of before that, but
we'll see if I can make it by SIGGRAPH.
That'd be cool. I'm sure we can rent a little parking lot next door.
You see. So maybe detecting a cone in the sim and detecting a cone in the real is the MVP. Well, I think if we already had a model that could see the cones and the environment and drive off of that, I see the MVP is a model that only sees cones. And the way we do that is by randomizing the background, so it just can't depend on the background for any of its information, because it never knows what's going to be there. It can only depend on cones. So great comments, great questions. Oh, could you also switch between USD layers for scripting replicator synthetic data generation? For example, switching between different progress state layers. Yeah, I think you totally could. I think, and I haven't quite figured out how to do this, but the way I would do that is if I had the click coordinates and saved to the USD layer as some kind of metadata, then you could have the replicator run, just open up the scene and have replicator open, just activate one delta layer at random, randomize it, and just, can work that way. I don't know if replicator can activate and deactivate layers, and I don't know. So I don't know everything about that one, but no, great thoughts. Is it working in the real? The MVP is working in the real. That's right. Because that's the whole point of this next step. We've got it working in sim, no problem. We've got it working in sim. The next fundamental step is to essentially get the same car working in the real world. And I think for me, there's some practical considerations there that I don't want to really carefully control the background, because I think that's not scalable. Doesn't scale to real world situations. And I don't want to have to spend hours and hours just exactly setting the track up the way it is in sim. There should be a little bit of forgiveness there, right? How do we mount our Jetson on the vehicle? Like that. This is the real car. Remember that this car, this asset, is measured and weighed off of this one. It has the same dimensions, suspension geometry, and material properties, or mass properties as this car. So I actually weighed the parts on this. I actually measured it in CAD to match it, and built a simulation. So this is an F1/10th car. Let me pull up a link. Yeah, this is a standard platform, a little bit higher performance than the Jet Racer. And if you look at their build, they're using a Xavier, Jetson Xavier, one of the older ones that's fairly expensive. But just swap it out for a Jetson or Nano, and don't do the LiDAR, just do the camera. And that's what we're doing. So that just saves some cost for everybody. And it does have a stereo camera. We're not using that yet. So if you wanted to just get a single camera and mount that instead of the stereo camera, that would work fine for now. I think eventually we'll want to use a stereo camera. It gives a lot of useful. I think for reinforcement learning, we're going to want that. We're going to want that stereo camera so we can detect depth. It's the Aura Nano dev kit accompanied with, so this is a Traxxas slash chassis, or Traxxas slash base chassis. It's actually got the lower. If you buy the Traxxas slash Ultimate, you've pretty much got this. It's a Traxxas slash with a lowering kit and a brushless, and then a 3-cell compatible brushless motor. The 3-cell brushless motor is important, I've learned, because 3-cell battery has got enough voltage to run the Jetson just by plugging it straight in. So if you get the Traxxas slash Ultimate, it'll be right for you. And the battery on the Ultimate, if you just plug it directly into the Jetson, will power the Jetson without any kind of voltage upscaler or any of that kind of stuff. So that's what we're doing. We're playing with F1/10th. Any questions? I think that's it. I think, yeah. And this is where I would love to, if someone wants to do the Jet Racer specifically, then reach out to me and I'll show you how to pop it. Then what I want you to do is take my template, that's the F1/10th, fork it, and edit its dimensions to make it the Tamiya TT02, and release your own open source robot, guys.
That'd be awesome.
Be the first one to fork an open source robot and release it. That's why we're doing That's why we're doing open source with Onshape. It's because with this one, you can get a free Onshape license, make a fork of my car, and adapt it to yours. Yeah. Yeah, unfortunately, I don't know. I can't make any. I don't know about Thor. I don't know. If I did know, I wouldn't be able to share internal release dates anyway. But I can say I don't know. So can either, I don't know. Yeah. So, and yeah,
I think that's
what
time, man.
that's time.
That
It's
is
been a
time.
pleasure meeting, talking to you all every Thursday. And
Absolutely.
but like you see here, I hope I hope you see that I'll be back, just not quite as often, but with cooler stuff, right?
Yeah.
So, all right.
All right. Thanks,
Everyone,
everybody. Thank you,
yeah,
Eric.
we'll talk to you later.